Welcome back, guys. Happy Friday to you. We are on day 4, and day 4 is all about getting more and more of this word right here: practice, practice, practice. Big day, part 2, and that's why today we're going to have a lot of individual work. So if you're wanting to get a little bit more practice in, today is your day. If you're still feeling like, hey, I need to keep working with these theorems and definitions to make sure I got it, then today is your day. Don't forget, if it were me, I would 100% have out. I would have my day 3 handy. I think having my day 3 with all of the definitions right here would be super, super helpful. So I would say have day 3 on standby. And what I'm going to have you guys try, all of these are kind of disjointed. And I'm going to have you guys try numbers 1 through 11. I know that sounds like a lot, but remember, we're just kind of working through each of these individually. These are not connected. I want to make sure you understand. These are not connected. One statement does not lead into the next. So go ahead, guys. You can pause the video and give this a shot. 1 through 11. Okay. So the big thing here was, hopefully we felt really good about these first 6. We had subtraction. Subtraction number 2 is actually a 2-stepper. Call out Little John. Subtraction and division. Number 3, we add 19 to get the addition property. Number 4, we combine like terms and then add 9 over. I'm sorry, we didn't add 9 over. We combine like terms here in order to get 13x. That's CLT. Number 5, we straight up distributed. And number 6, we had an angle equals itself for reflexive. Now these last 5, I wanted to make sure we talked about. Hopefully you guys already knocked them out. But a lot of people get 2 of these that we're going to talk about really confused. So number 7, if angle 7 is equal to 2x plus 1, and angle 9 is equal to 2x plus 1, then angle 7 is really equal to angle 9. Do you notice how we have repeats here? That and that are both equal to these individual angles. Well, let's cut out the middleman. Let's say, okay, if angle 7 is equal to the same thing as angle 9, then they're going to be equal to each other. That's the transitive property. How about number 8? If x equals 9 and 9 equals z, then x really equals z. Isn't that the same thing? Yeah, that's transitive as well. Now how about this one? If 4x plus 17 equals b and a plus 1 equals b, then 4x plus 17 is really equal to a plus 1. Isn't that also, that's also the transitive property. If you say that because 2 things equal the same thing, we can set them equal to each other, that is the transitive property all the way through. As opposed to, check out number 10. If angle 5 equals x plus z, and a piece of this equation, x, is really equal to 6, you notice how they're not the same thing here, then really angle 5 is equal to 6 plus z. So what happened here? Oh, we substituted in 6 for x. That is substitution. And then last one, ooh, this one's a little weird. We've got some math up front. Angle 6 plus angle 9 equals 180 degrees. And if that happens, angle 6 and 9 are supplementary. If the math comes first, you guys know the drill. The math comes first before the subject. You know the drill. We're looking at the converse of the definition of supplementary. Okay, hopefully you're feeling pretty good about that. Now, here's where we got to be extra careful. If you're actually dealing with a proof that is connected, right? We're using this figure over here for the next 6. It's going to be very important that you not get your definitions and proofs and postulates mixed up here. So first off, angle 3 plus angle 4 equals angle COF. So angle 3 plus angle 4 equals the whole angle. Now, does that remind you guys of something? Absolutely. We're talking angle, add, post. How about number 13? COF is a right angle. Oh, straight up. It's just a right angle. You guys know the drill. If they just give us a definitive statement, we're talking the definition of our subject. That's the definition of a right angle. Holla at your boy. Sorry, I apologize. It's really cringe. Now, if COF, whoa. We got some math up front here, is equal to 90 degrees, then COF is a right angle. Math first. What are you guys thinking? I'm thinking the same thing. We're talking converse of the definition of a right angle. You know it. How about number 15? COA and COF are a linear pair. Okay, so we're busting out the linear pair talk now. If they just give us that declarative statement, they're a linear pair, then we're talking definition of a linear pair. You guys, I hope you're starting to see some patterns here. That really is the key here when we're working these, is that a lot of times there are patterns. Definitive statements are definitions. Math comes first. That's a converse of the subject. And so what I'm going to do is I'm going to let you guys try numbers 16 and 17. See if you can finish this for me. See if you can take care of this. All right, 16. If this is a linear pair, then they are supplementary. That's the linear pair postulate. And angle 2 plus angle 3 equals BOD. That would be part plus part equals the whole. So angle, add, post. All right, guys. So before I turn you loose on a lot of the rest of this day, and to the point where we're going to be checking, but it's going to be a lot of you kind of going back through our definitions and through our theorems and working individually. I just want to look at 18 and 19 real quick, because the rest of these you're going to see these are connected. So like 18 to 22 is all a proof. 23 through 28 connected. 29 through 33 connected. So kind of keep that in mind, guys. And actually, I'm sorry. 29 through 33 is not connected. These are not connected. I was thinking on the next page. That's my bad. But back to 18 and 19 real quick. It can be really difficult sometimes to know whether we're dealing with symmetric or commutative. That can sometimes be really difficult to understand which one we have because they can look so similar. Just remember this, symmetric is flipping an entire equation. Symmetric means that if you have an equation, we can completely flip that equation, both the left and the right side, and it's still the same thing. Whereas commutative is just saying, hey, if you flip one side, it really equals itself. So for example, number 18, 5x plus, if 5x plus 1 equals 17, then 17 equals 5x plus 1. Well, in this one, we flipped the entire equation. We took the left side and the right side and completely flipped them around. So that would be symmetric. Whereas on number 19, I'm sorry, t plus v is equal to v plus t. Oh, they just took the left side, flipped it around, and said, hey, it's still equal to itself if you flip it. That is commutative. And once again, I don't know why I told you that 18 through 22 is connected. I must be off. Phew, I must have been here for too long. Those are not connected. So apologies there. Now 23 through 28 absolutely is. So what I'm going to do is I'm going to let you guys, and I know this is more work than I usually, do without helping you or working with you, but I really do believe the best way to master these is to practice them on your own, go back and look over the theorems and definitions, and then kind of get down, okay, here's what I see. Here's what I know this is going to be. It's practice. This is all about practice. If you can practice these and get good with identifying them, this chapter is going to be a whole heck of a lot easier. I promise. Practice makes this chapter easier. And you guys are so smart. You really are. So let's take some time and let's work on 20 through 33. Let's see how you guys did. Number 23, part plus part equals the whole. That's some seg-add post. How about this one? If DE plus EF equals DF, then we can replace DE with 3x plus 5. We can replace EF with 5x minus 13, and we can replace DF with 24. That's straight up substitution. I kind of spoiled that one. If we have this, then we can simplify it to this through combining like terms. 3x plus 5x is 8x, 5 and negative 13 is negative 8. Then if 8x minus 8 equals 24, we can add 8 over to get the addition by the addition property. And finally, we can divide to figure out that x equals 4. And if x equals 4, and we want to know what EF is, then we take 4, we substitute it in for x, we work it out, and you find out that EF is 7, thanks to substitution. Now these last 5, I'll just show you guys. And again, I want to bring special attention to number 33, Larry Bird here. If angle 8 is equal to angle 10, and angle 8 is equal to angle 11, then really angle 11 is just equal to angle 10. We can cut out the middleman, cut out what repeats, and find out what really is equal to each other. So we will stop there, and part 2 of day 4 will be coming a little bit later today. So part 2 of day 4 later today. I'll be seeing you guys soon. Later today, in fact.